Welcome back to Java Code Academy. Today we learn in Java linked list. In the last video we mastered the array list. It's great, but it has a secret weakness. Imagine you have a list of million songs. If you want to add a new song at index 0, the array list has to shift all 1 million other songs over by one spot. That is incredible slow. Today we meet the solution, the linked list. Now today's topic is the linked list. Now I'm moving to the topic. I want to say the comparing difference between array list and linked list. Array list is one solid block of contiguous memory. Linked list is scattered block connected by pointers, no contiguous memory. This is the major of the linked list. The node autonomy of doubly linked list. Previous pointer links to the neighbor behind. Data. The actual value stored in the node. Next pointer links to the neighbor ahead. This is defines a double linked list. Unlike arrays, a linked list does not store data in one solid block of memory. Initiated, it stores data in separate containers called nodes. What is meant by nodes? If ask a interviewer, you can simply say initiated store data in separate containers is called the nodes. Think of a treasure hunt. Each clue node has two things. The data is the treasure. The address of the next clue, the pointer. In Java, the linked list is actually a doubly linked list. This is means each node knows who is next to it and who is previous to it. How it works in memory. Let's look at the memory. Array list, everyone is sitting side by side on a bench. If a new person squeeze in middle, everyone else has to scoot over. Slow insertion. Linked list, everyone is standing randomly in a room holding hands. If a new person joins, two people just let go of hands and grab the new person. No one else has to move. It is the fast insertion. This is the major important point. The code, it looks the same. Yesterday I declare about also the it looks the same. The cool thing about the collections framework is that the code looks identical. Now I open my IDE. Now I execute the linked list one of the code. I create a one file in my file folder that is a linked list. It is today we said about the we're learning about linked lists. Now I linked list dot java. This is a Java extension. Public class. First we imported the all packet all components in Java. Import. Sorry, my keyboard is not working. Java dot util dot util dot start. This is our total import components in Java. Now I write a class function. Class is linked list. I want to write a main function. Looks how similar this is to ArrayList. Linked list of. This is the what is string is here the garbage where the garbage value. Now I write a names equals to how I declare new linked list. This is our basic initialization. Yesterday I already said about in. Now I want to add something in our linked list. What is the variable? Variable is names. I wanted to add the string. One of the string is my name. I want to add the my name. This is my name, Srinivas. I want to add some other names also. This is the string. I want to the garbage value. I declared the string. So we assign the values only strings. When you are assign the integer garbage value, you can see assign it like integers also like numbers or anything else. System dot out. Sorry, my keyboard is not working. Println of names. This is our simple and clear array linked list declaration. Now compile the linked list. We want to see the output. What is linked list? Output see here. You see the list of arrays. You can use dot add and dot remove get just like before, but under the hood Java is doing something totally different. This is the performance of our get index and add index. When you are add index, our time complexity is very slow. It is big of log. In array list, it is only array list. I want to difference between in array list time complexity and linked list time complexity. We isn't here. Get index in linked list, it is very slow. Add in linked list, it is very fast. And add at n, add index means you can specify the suppose we have given an array like 1 2 3 4. You index specifying like that 0 to and n, that is the index specifying. You can index specifying is fast in linked list. Add the at n means you can add any integer or string or anything else. Both are very fast. In array list and linked list are both lists are very fast in collections framework. The memory is in array list overhead, high in linked list. A linked list requires extra memory for pointers leading to higher overhead because that time complexity is specifying starts with big of O. You can clearly understand in DSS series. After the Java series completed, then I move to the started DSA. I explain the clarity how to define the time complexity, how this everything I will said about that. When to choose linked list, stacks and queues, ideal for implementing these data structures. Frequently modifications, efficient for insertion deletions in the middle of the list. Dynamic size, no resizing cost when data size is unknown, unfound. Linked list advantages, dynamic size can grow or shrink easily. Adapting to data needs without fixed capacity issue. Efficient insertion and deletion. Added or removing elements, especially in the middle, is very fast, big of one. No memory waste. allocates memory only as needed, avoiding pre-allocation waste. One of the basic three disadvantages of in linked list: higher memory overhead. Each node stores pointers, consuming more memory than array list elements. Slow random accessing an elements by index, requiring traversing from the beginning of big often. Catchy performance. Non-contiguous memory can lead to poorer catchy performance. This is in case study beyond stacks and queues. You have a music player playlist, easy to add and remove the songs and reorder them. This is the linked list of that example. You take the in real world example, and one of the web browser history navigate back and front through visit pages and undo redo functionality, managing sequences of operations at reserved, comparing memory and footprint. ArrayList stores only data, making it memory efficient for larger data sets where random access is frequent. In a linked list, each node requires extra space for pointers, increasing memory usages, especially for small data types. Takeaways: choose wisely. Select linked list for dynamic data, frequent modifications, and unknown sizes. Performance trades off: understand the big of one for insertion and deletion versus big of n for random access. Memory consideration: be aware of higher memory overhead due to the pointers. The when to use guide. So I don't use linked list for everything. The reading problems: if I ask the array list for items, it jumps straight there, big of one. If I ask the linked list for items, it has starts at item 1 and say, are you 5000? No, go to next. It has to walk the whole chain, big of n. Use ArrayList 90% of the time when you want to access the data fast. Dot get and mostly added to the end. Use linked list when you are building a queue or stack or need to frequently added and delete items from the start or middle of large list. Now you know the two giants of the list world. Next time, we enter the world of unique items with the set interfaces, that is asset. Subscribe to Java Code Academy so you don't miss it our upcoming videos and upcoming tutorials. Please like, share and subscribe to Java Code Academy. Please support me.